at least I know I should prepare something for you. Okay? Right, please have a seat. Let's finish up these two chapters.
챕터
동의어 11분 하지고
大家好啊，不要理解。
Okay, Richard, have a seat, have a seat. Later. Okay, chapter 9 is about continuity. The only continuity that we are studying in this semester, this syllabus, is mass continuity. Now, mass continuity has very close relationship with steady flow. Steady flow is a flow where there is no change of properties of flow with time. So, mass flow rate in a steady flow is always a constant, right? If the flow is of liquid, that means the liquid is incompressible. The density is constant, therefore the volume flow rate is also constant. Okay? But if the flow is gas, can you say the volume is constant? The volume flow rate is constant? No, it is not constant. Put it that way. Okay? So, liquid flow, mass flow rate is constant, volume flow rate is constant. Gas flow, mass flow rate is constant, volume flow rate may not be a constant. Because you have to check the temperature, you have to check the pressure, you have to check the geometry of the flow, blah, 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 blah. Okay? And in all your questions in this particular syllabus, we will only deal with steady flow. Do not worry about it. Right? Okay. M dot is rho AC. Okay, given in your exam, so no problem. V dot is AC. Area of the cross section multiplied by C. C is the average speed. But we can just take the flow speed at that point, no problem. It's just the same thing. This equation is not given, and because of the fact M dot equals to rho AC and V dot equals to AC, so this AC can be replaced with V dot, so M dot is equals to rho V dot. Very useful for you. Okay, based on the equation that we have seen during the tutorial. No, there's no derivation. We never go through that. If you want to go through that, you need to learn something called normal unit vector. Then we have to go back to calculus. So that is for your degree. During your degree, you'll do this. dp dt plus dp dx dot n plus dp dy dot n plus dp dz dot n. N is the normal vector. Okay. All right. Yeah. Any doubts? Okay. These formulas are this is given. This is not given. This I expect you to know. Not given also. So please remember. All right. Okay. You can show this. No problem. All right. Let's go to the big guy. Bernoulli equation. That's very popular. Always in the exam. So take note. Right. Know each and every single thing about Bernoulli equation. Right? Know the conditions to apply. Know the assumptions to apply. What are the assumptions needed to apply Bernoulli equation? Number 1, steady flow. Number 2, it is valid only along a streamline. Number 3, friction and other viscous forces are neglected. These 3 major assumptions are important. Okay? These 3 major assumptions are important. Okay. I noticed that some of your seniors, they like to use the word, it is only valid for incompressible fluid. Bernoulli equation is only valid for incompressible fluid. This is wrong. Okay? Bernoulli equation is valid for both compressible, non-compressible. So in other words, it is valid for liquid and also gas. Okay? So do not use that line. So whether it's compressible or incompressible, you can still use the Bernoulli equation. However, it's not part of our syllabus to learn compressible. That's why I'm not teaching you. But that doesn't mean that it's not there. It is there. We are just not looking at it. So 3 things. Steady flow, number 1. Number 2, along a streamline. Okay. Number 3, friction and other viscous forces are negligible. That means we realize they are there, but we are neglecting it. Okay. Speaking of which, you should know what is streamline. If you have a pipe or any flow between point 1 and point 2, you could model the flow in however many different ways that you want. You could say that the flow is straight line. You could say that the flow follows this line. You could say that the flow does this. No problem at all. All are valid as long as, number 1, they are continuous. That means between point 1 and point 2, it is a whole line. Okay? Between point 1 and point 2, it's not stopping. In other words, you don't have this. There's no stop. There's no discontinuity. If this happens, how many streamlines are there? 2 streamlines. No more single streamline. So you need to use one Bernoulli equation here. You need to use one Bernoulli equation here. So in other words, you need station 1, station 1.1, station 2, station 1.1. Or maybe about, if it's the same, then 1.1 or maybe 1.2. Depending. So it's more complex. So continuous. Okay, that's number 1. Number 2, no 2 streamlines are to cross one another. So if there is one path, only one streamline goes to one path. You understand? So in other words, this zigzag guy cannot zigzag his way to this. Not allowed. Okay? In theory. In theory. Alright, so this is just the definition. You don't need to worry about the details. Clear? Right. And I taught you how to derive the Bernoulli equation based on SFEE. Stick to that. Stick to that as part of our syllabus. Right? And don't forget, when towards the end of derivation, don't forget to include V equals to 1 over rho. Because most of the seniors, they tend to leave their Bernoulli equation with V's. Okay, which is not part of it. Right? To make your life easy, I've given you this thing in your formulation. Okay? Right, so take that as a note. And also, please, when you're asked to derive, leave your answer in either pressure form or the height form. Those who have gone through the tutorial, you should know. Or the height form. Up to you. Don't leave this as the final line of working. Okay? Right. Okay. Right. Okay. Now, in a pressure form, this is how it looks like. You have 3 terms. P, rho V square over 2, rho GZ. All 3 things are different types of pressures. Static, dynamic, hydrostatic. Know the definition. Okay? Know the meaning. If this is confusing, go and Google up. Okay? The height form, also same thing. You have 3 terms. Static height, dynamic height, hydrostatic elevation. All 3 things, you must know the meaning. Okay? Yeah. Static height. P over rho G is static head or static height. Okay? Sometimes it's called pressure head. Sometimes the second one is called velocity head. Right? Yeah, so many names. Okay? Right? If the question asks for head form, the question can ask in pressure or head form. Huh? So please remember that. You need to know both. You need to know all 6 terms. No choice. Right? That's all. Okay? So far so good? So, when it comes to a question on Bernoulli principle, I've told you, you have the freedom to choose the stations 1 and station 2. Choose the station which is easy for you to put the datum point. Put the Z1 and Z2. If possible, make either Z1 0 or Z2 0. So that your calculation is easier. Alright, any questions? Any questions? No questions as of now? Alright, okay. Let's do one simple example.
这课不是到7点钟来吗？哎呀，这课要几点？
6点。
你这个让你回家。
看不到我回家了吗？移到哪去了？去的。
你给我钱，我帮你付。我要纸币，谢谢。不要拿1000、1万那种来给我，我要马来西亚纸币。
外国纸币不可以啊。
哎，好啊，你给我$，我没关系啊。
我讲要给多了。哎，还手指讲哦。
哎，那我们有这样，没有这种。
我鼻子。
你问我原因？
说啊。
哎，不要告诉我。
别看。
没有，真的不会有耶。
选哪个？哪个？
你闺蜜。
这位？
对。
好。多吗？多方便。
可乐有冇卡乐啊？卡乐点评他们咯。
要几点啊？他们点点。
2点，早上是蹦好像10点多，10点多有一次，过后2点半有一次，然后他们2点半过后4点多就出来了，2点多进去里面好像是进去了过后4点多出来了，好像是要。
Okay, right. So please take note of this question. Alright. Okay, question is, right, so just draw this figure. This is a pipe with two bends. A pipe with two bends, B-E-N-D, okay, is shown in figure, right? The distance between the bend, okay, the vertical distance between the bend is 30 meters. The vertical distance between the bend is 30 meters. Okay? The inlet diameter, or in other words, D1 is 12 millimeter, D2 is 25 millimeters. Right? D1 is 12, D2 is 25. Okay? Oil flows through the pipe. Oil flows through the pipe, okay, at a rate of 0.4 liter per second. Those at the back, stop laughing. Oil flows through the pipe at a rate of 0.4 liter per second, and the relative density of oil is given as 0.82. Relative density of oil. D1 is 12 millimeter, D2 is 24 millimeters. Okay? Okay so far? Right? If the pressure at inlet is 5 bar, if the pressure at inlet is 5 bar, find the pressure of the flow at the outlet. If the pressure at the inlet is 5 bar, find the pressure at the outlet. Pardon?
Bữa trước trên chịu khoai mấy. Ủa, sao trên đó trên chịu khoai rồi?
我很精致而已，你看这样子，精致，拍出好的 video，
YouTuber。
我赚钱了哈。
超大都可以。
Okay, since you're running out of time, let's make a start. Right. You are asked to find P2. You are given P1. You have an inlet, you have an outlet. It is a pipe flow, correct? So, what must your first line be? That's right. Assume steady flow. What's flowing in the pipe? Oil. Oil is liquid. If it's liquid, it's incompressible. If it's incompressible, V1 dot must be equal to V2 dot. Call the inlet as 0.1. Call the outlet as 0.2. Liquid, for our syllabus, it's incompressible. Not all the liquids are. Some liquids are compressible though, but we are not looking at that. Okay? If it's not liquid, if it's gas, how does this change? We cannot use volume flow rate constant. What would you use then? Mass flow rate constant. Can we use mass flow rate constant for liquid? Can, but no point because the density will be cancelled. We will end up with this. So, might as well start with this. Okay? So, A1 C1 equals to A2 C2. Right? A1 pi over 4 D1 squared C1. A2 is pi over 4 D2 squared C2. Yeah, big V. C is big. Right? C1 equals to D2 over D1, the whole thing squared C2. I've done this before. Yeah, tutorial. Because it's the same thing. One flow, one inlet, one outlet. It's steady flow. This is how it's supposed to be. Find the ratio. Find the ratio. C1 equals to D2 over D1, 25 over 12 square C2. So C1 is equal to 2 point. I should have made it 24, but never mind. What's the answer, please? 25 divided by 12. 2 point? 2.08. 2.08 square C2. So C1 is equals to 4.3? 34 C2. I have this, but this is not good enough because this is not what the question wants. Alright, but this is a good start point because I know that I have my C1 as C1. I know I have my C2 as 4.34 times C1. So there is a hint for me to play around with. So, what's next? Question is asking for pressure, so use the okay, use the Bernoulli equation, which is
P plus rho V square. No, I use pressure form.
if you want to ensure you get good marks, you start with the statement given, okay, and show a bit of working that you're multiplying with the pressure. So this will be hey, what am I doing? Okay? Right. So once you have established this, then go back to your geometry and start to figure out where should I put the datum point. You have the freedom. The best is to choose this as the datum. So when you do this, what's your Z1?
0.
What's your Z2?
30.
30 meters. Okay? What's your P1?
5 bar.
You have to set the datum. You can set the datum wherever you want. You can set the datum to be here. No. Z2 will be 0. Z1 will be negative 30. You can set in the middle also. Z1 will be negative 15. Z2 will be positive 15. But I'm sure you won't do that. Right? So make your life as easy as possible. Right? P1 is 5 bar. Row 1 is 820. C1 is C1. Okay? Z1 is 0, so this whole thing will be 0. P2 is what you want to find. Row 2 is the same as row 1, 820. C2 is 4.34 C1 square. The whole thing, don't forget. Plus row G 30. Row is 820, G is 9.81. One equation. One equation, how many unknowns? 2 unknowns. How do you solve? See, what did you do? Yeah. Pardon? C1 and C2 terbalik ah? I don't get you, I'm sorry. Oh. Correct lah.
Correct.
Correct lah. This is correct, right? So this is correct, right? So this is correct lah. No. Wait. Oh yeah. C1 is equals to 4.32. Okay, let's make it this. Doesn't matter lah. I'm not going to sit for exam. Okay, good, smart. Thank you. Okay. But never mind, the problem here is we do not know C1, we do not know C2 because we do not know P2. In fact, it's the other way around. We do not know P2 because we want to find P2. How do we solve it? Sit down and cry. No. It turns out we got carried away with what we have done before, right? But think about it. What is A1? Area. We have the diameter, we have the area, correct? We have the V dot, correct? So, 0.4 is equals to A1 C1. Right? Sorry, 0.4 liter. So 0.4 times 10 to the negative 3. Because I want to show you meter cube. Equals to A1 C1. It is the same thing as A2 C2. So from here I can find my C1. Then I can find my C2. Plug it in, get the answer. That's all. I purposely did this to show you that you should not get carried away. Your job is to take note of all the parameters given to you. That's why a diagram is super duper important. Try to redraw the diagram, put in all the values that you have. 0.4 liter per second is your V dot. V dot is AC. Diameters of two sections are given. Volume flow rate must be constant. You can find C1 actually in the beginning. You can find C2 also in the beginning. Yep. I wanted you to think. Thank you. Okay, so I believe you can do this because everything is presented. Just find the C1, C2, put in, find P2. Your answer should be... I changed to pascals because I want everything to be SI units. Yep, see you.